my name is Brian, and this is my groupmate for the city assignment, Gary, Hao Ming, Fiona, Chi Hui, and Awai Chong. The title for our assignment is to interview the BI engineer named Danny Ng Wee Kiat. He is MMU graduate and currently taking his PhD here in Utah. He is also the advisor for the Robotics Society here in Utah.
So we'll be interviewing him for the device called biopotential amplifier. This device is to trace and assess the signal of a human brain. So this is the design draft of the device. Let's go into details for the interview section.
I'm Daniel, graduated from MMU last time, taking electronics. So recently just got my master's degree here in Utah. So I've been actually designing biomedical circuits, amplifiers especially for all those electroencephalography, electrocardiography, electromyogram. So mainly all those biopotential amplifiers, I did designs on them. For my master's studies also I did a few devices, especially EEG and also the amplifiers to measure neurons activities. So all these designs are actually mainly done by me only. So what I have here is one of the example of a device I've used. This is EEG amplifier. So basically, any question from you?
How does this device work? How it works?
Okay. What you have over here, right? So there's an amplification stage here. Then after the amplification, there's this is analog to digital converter. Then you have this USB controller over here. So to make this work, you see there's 3 pins over here. This is a device designed especially for taking EEG on the part where you are looking at on the visual region of the brain. So you use one electrode as reference. Then this is the 2 pins for you to connect the 2 electrodes to get the differential between the 2 regions. So you actually connected these 2 electrodes to the back part of your brain. Then this reference electrode to somewhere else as a reference. Usually we'll connect it to our cheekbones over here. So the electrode will actually pick up the signal. Amplification here is 20,000 times amplification. So after amplification, it is taken into this DAC, converted into a digital value. So there's a firmware here passing the values to the PC through USB. Every second there's a 2000 sample to the PC. So basically this is how it works. On the PC sides there's a program to capture all the data and display it out.
So how long you taken to do this device?
Recently in there's one event going on in Kedah. So we actually built this purposely to demonstrate the SSVP, the statistic evil potential of our human brain to the visitor over there. So this device took me around a few weeks to actually get all these components and all these things out. So after that we just test it, we demo it to the public.
What type of amplifier is this?
This is actually a 3-stage amplification. The first stage there's instrument amplifier, which is very small here. I don't think you can get it over there. So after the first stage gain the 1000 amplification, then there's a 2-stage non-inverting first order active amplifier. So
Inverting person.
so it's non-inverting, both non-inverting. So after that you got the 1000 over here, 10 over here, then 2 over here. So a total gain of 20,000. So this is the amplification stage.
Then what about what do you do for noise reduction?
Basically for this, right, there's two filters. Then there's a driven Rayleigh circuit. So the common mode voltage is actually feedback to the human body to actually reduce the noise through the reference pin over here.
But what filters are you using?
Basically it's only the first order low pass and first order high pass, because most of the noise are actually suppressed by the driven circuit.
Then for the electrodes, when you are connecting to the human body, do you need anything as
There's skin preparation before that, so we actually have to, there's a mild abrasive we use where to clean up all that skin or all the unwanted layer and scalp on your scalp here. So we clean it up a bit.
do you need
Then
to shave?
no, don't need to shave. You just open up just open up the hair a bit, then you can access the skin. But that depends on person. Some people having a bit dense.
So we
And
actually need to scrub the layer.
it's a mild abrasive, so it's just a minor scrub. So just clean off, then we clean it off using a cotton bud. After that we apply electrode gel, then we fix the electrodes. So because it's we test it with the general public, so it takes quite some time to actually test each person. That
How long does each period?
To actually prepare a person, it will be around, because it's only 3 electrodes, so it's quite fast, around 5 minutes to 10 minutes per person. Because at the same time also we explain to them what is EEG, because most of them are general public, which try to share this knowledge out to them.
Is how much does it cost for each period? Each time you use for the electrode and
Because the electrode we use are reusable, so we don't count it each time. But one electrode, if you buy one electrode, will be around 50 ringgit. So it's actually a gold-plated electrode. Then for this circuit, it's actually quite cheap here. It's around 200.
So would you mind to explain to us what is EEG?
Okay, EEG is actually the electrical activity of your brain. Some other people call it brain signal. So every time we are thinking, even though we are not thinking, so there's actually electrical wave that you can detect from your brain. So it is actually classified into different states. When you are doing certain things, your brainwave will have a certain frequency. So EEG is a measurement of that frequency to determine what is the state of our brain activity. So when we are relaxed, you can see alpha wave is roughly around 10 Hz all over your brain. So you can actually see that when you are closing your eye, then not thinking about anything. Higher frequencies will actually mostly they are linked to thought process when you are thinking, when you are doing something. So that is the higher frequency, more than 10. So then there's a very low frequency when you are sleeping. So basically that is a measurement of our brain activity.
So is that like some kind of device that to test whether are you lying or then your frequency?
No. No, totally not. Until now actually there's no concrete proof how the brain activity relates to lying.
Then this means that when you are nervous, like you are very very nervous, then your brain activity will be very very active, right? And the wave very
Still again,
does it relate to IQ?
no also. We actually got the same type of question when we are setting up our booth in Festival of Minds. Same type of question from the general public.
So you actually want to know whether we are relaxing or what is it?
It's just a health.
First thing is we know that the relaxing state can be seen from there. Then actually each part of our brain is correlated to a different type of bodily function. So the back part here mostly related to our visual. Top part here is on all those motor function. So your hand movement, your arm movement, your leg movement. Then the frontal lobe is mainly on the cognition. So when you are doing different things, different part will be activated. So how much you activate doesn't relate to how good you are.
Oh, so it doesn't mean that like an unhealthy person will have a different kind of way than a healthy.
An unhealthy person, if there's something happen to their brain, yes, they might have a different type of signal, roughly different type of signal. So, but that will be up to the doctors to see. So, not the engineer.
Okay.
Good, eh?
So about the circuit is using op-amp, right?
Yes.
What's
but,
the difference if you are using transistor instead?
you won't be able to achieve those noise level that you will be able to achieve using a transistor. So if you are using a single transistor, then there's no way you can achieve such good quality amplification.
Meaning transistor is not as good.
Actually, op-amp is actually built out from transistors also.
Okay.
So it consists of a lot of transistors, but they have. If you take a basic transistor circuit for amplification, you add a bootstrap capacitor to actually reduce the input bias current. You add a few transistors to generate a low impedance output stage. So it can actually be as good as an op-amp, but the circuit will be very complicated.
So it's a simplified.
Yes, I can say so. Everything built into an integrated circuit.
So what's the costing for this device?
What you see over here, right, it would be somewhere around 200 to 300 ringgit.
200 to 300 ringgit.
Yes. So including the electrodes.
Oh,
So what you see here is actually not that expensive. All those electronic components are actually quite low, but the development cost might be quite high for that.
development cost will be quite high.
What's the lifetime of the electrodes? This one is low-rated.
Depends on if you are using it every day like this, 8 hours, maybe around half a year. So then the gold plating will usually wear off.
When you eventually wears off, then you can't use it anymore.
Yeah, we just throw it for recycle, then we buy new one.
But is there why exactly do we need gold-plated electrodes?
The gold-plated electrodes, right, will actually provide you a good impedance connection to our human body. And we tried before silver electrodes. They are also selling silver electrodes, but it doesn't last as long as the gold electrode that we have.
What about maybe platinum?
Platinum is actually rarely used for EEG. Reason is, again, one thing, platinum electrode now is actually more expensive than the gold-plated electrode. That's one of the reasons. Secondly is the half-cell potential is actually a bit more compared to gold. So
it's more cheaper and still
more reliable.
Is there anyone who cannot undergo this?
EEG.
There's no one that cannot undergo this EEG, but if you have metal implants, or usually you won't have metal implants in your brain, but those that might have accident might have metal implant in their skull or something like that. So it might, we might not be able to pick up signal from them. So it's only them. Other than that, all the people can go through this.
But it's not dangerous. I mean, for them, just that we can't pick up.
We can't pick up the signal. it's not dangerous.
So for the question like people like in coma, like they'll same giving out the brain signal. Like,
There is some cases reported in publication journals. Certain coma people still exhibit brainwave activity that is similar to active person.
so it will be traced by this device.
Yeah, something like this, but just imagine this is a single channel over here. You just imagine 64 channel, 64 of these.
So this will be the same.
This will be a single channel unit, yes.
After going through this video, all of you might wonder that having multi-electrodes stuck in your brain, will that thing cause any permanent harm to your human body? But the answer is actually no. But one interesting fact is, in order for that device to work perfectly, you must not have any metally element planted in your brain. And however, you do not have to worry, because this device will not affected by your thoughts. It will work perfectly when you are relaxing. It will just work. Thank you for watching.